Dear students, today we shall learn properties of states of matter. It's the article number 1 in Unit 1 Chemistry EDEXCEL International GCSE 921. We shall answer the chapter questions, question number 1 to 3, given on page number 12. First of all, we start with solids. Solids have a definite shape and definite volume, and its particles are tightly packed, vibrating about a fixed point. They do not have enough space among each other to move from one place to the other. They restrict each other's movement, so only the particles can vibrate to and fro motion around its original position. Liquids have an indefinite shape, but they do have definite volume. Particles of liquids are tightly packed but are far enough apart to slide over one another. Like that, you can see that these particles are not arranged. They do have some different small spaces among each other. Then so that they can slide over and can change their shape. Now gas. Gases have an indefinite shape and an indefinite volume. Their particles are very far apart and move freely. Very small amount of particles are in a particular and the specific volume. So they do have space so that they move very freely from one place to the other. Fourth state of matter is plasma. A plasma is an ionized gas. A plasma is a very good conductor of electricity and is affected by magnetic field. It's different from gas in that way that it conducts electricity and it is affected by magnetic fields. Plasma, like gas, have an indefinite shape and an indefinite volume. For example, lightning, stars, including the sun, tail of comet, and sky lightning. That we can say that it is a gas which is charged positively and negatively. Like that, you can see this is a thunderstorm and the sky lightning, and here in the sky lightning, this is the plasma inside it. Now you can see physical states: solid to liquid, and liquid to gas, and gas to plasma. They change as the energy is increasing. Phase of matter is the state in which matter can exist as a solid, liquid, or gas. When temperature changes, matter can undergo a phase change, shifting from one form to another. Like this. This is an example. You can see this is ice. When it is melted, liquid, it becomes water. And then after getting some more heat, this water converts into water vapor. You can see that these are the interchanges of these three states. Basic three states are gas, solid, and liquid. But when we come up to plasma, we have the solid to liquid to gas to plasma. Back from plasma to gas, gas to liquid, and then solid. So this is the interconversion of the state of matter. Maximum of the time, solid, liquid, and gases, they do interchange. But when you have thousands and thousands of degrees Celsius, then gas can convert into plasma. Otherwise, it gets back to the solid and liquid. Here phase changes. Solid changes to liquid. This phase name is called melting. In melting, heat goes into the solid when it melts. When the liquid converts to solid, it's called freezing. In freezing, heat leaves the liquid, then it freezes. Liquid to gas. Basically, this is called vaporization. It has two parts. One is boiling, the other one is evaporation. Heat goes into the liquid as it vaporizes. Means the liquid converts into the vapors and goes into the gas. Gas to liquid phase change. As temperature of gas is reduced, it converts into liquid. This process is called condensation. Solid to gas. This is called sublimation. Heat goes into the solid and it sublimes. Gas to solid. This is called deposition, and heat leaves the gas as it deposits. Interconversions between three states of matter. Melting. Melting occurs when a solid is heated and turns to liquid. The particles in solid gain enough energy to overcome the bonding forces holding them firmly in place. The temperature at which the solid melts is called melting point. Opposite to melting, this is called freezing. Freezing is the process that causes a substance to change from a liquid to a solid. Freezing occurs when the molecules of liquid slow down enough that their attractions cause them to arrange themselves into fixed positions as a solid. It happens only when it is getting cold. The temperature at which this occurs is called freezing point. As you can see that this is happening melting. Melting is happening here because ice is getting heat from surroundings and it is converted into liquid, which is water. Happened now freezing. This is the opposite way. When the water of this lake got too cold so that its surface particles get so much closer to each other and they converted into solid. Boiling and evaporation, process by which a liquid turns into a gas. Boiling occurs when a liquid is heated so strongly that the particles are moving fast enough to overcome all the forces of attraction between them. Boiling point, temperature at which the pressure exerted by surroundings means the atmospheric pressure, which is 1 atm or 760 torr at the sea level upon a liquid is equaled by the pressure exerted by the vapors of liquid. You see that there are bubbles over here in it. When this water or when any liquid gets boiled, it does have the bubbles in it. Evaporation is a process where liquid turn into vapor. It occurs on the surface of liquid as it changes into the gas phase. When a molecule near the surface absorbs enough energy to overcome the vapor pressure, it will escape and enter the surrounding air as a gas. You can see that this is the liquid and it does have many molecules in it. During evaporation, more energetic particles escape from the surface, leaving the less energetic ones behind. Sublimation. A small number of substances can change directly from a solid to a gas or from a gas to a solid at normal pressure without involving any liquid in the process. The conversion of a solid into gas is known as sublimation, and the reverse process is called deposition. You see that the solids particles, they get heat from any source and they sublime. Sublime means these particles directly get converted into the gas state. And the gaseous state, when we take away the heat from this gas, which can sublime, so this gas get deposits. These particles get closer to each other and eventually it gets deposited and converted directly into the solid phase. Now chapter questions. Question number 1. What name is given to each of the following changes of state? Solid to liquid, it is called melting. Liquid to solid, this is called freezing. Solid to gas, this is called sublimation. Right now we have learned. Gas to solid, this is called deposition. Question 2. Draw diagrams to show the arrangement of particles in a solid, a liquid and a gas. So you can see, you can draw in this way. This is solid arrangement, this is liquid arrangement, and this is gas arrangement, as we have already learned. B part. Describe the difference between the movement of particles in a solid and a liquid. The answer is liquid vibrate, move about and slide past each other, whereas solid vibrate, jiggle but generally do not move from place to place. Question C part. The change of state from a liquid to gas can be either evaporation or boiling. Explain the difference between evaporation and boiling. Evaporation occurs on the surface of liquid, whereas boiling occurs at the entire length of liquid. You can see that from all over the liquid, when the liquid is boiling, its particles are coming out. But here, evaporation is happening only on the surface of the liquid. It doesn't happen in the whole liquid. Second one, boiling occurs rapidly, whereas evaporation occurs slowly. Third, evaporation occurs at any temperature, whereas boiling occurs at a specific temperature. Fourth one, the motion of particle is fast in boiling, whereas in evaporation, few particles move slowly and few at a faster rate. Fifth one, there is a formation of bubbles in boiling, but bubbles are not seen in evaporation. You can see in the picture, you can see the white bubbles are here, these are shown. But whereas in evaporation, you cannot see any white bubble here. So it's not happening in the evaporation. Question 3. Question refers to the substances in the table A, B, C, D, and E. A has a melting point negative 259 degrees Celsius and boiling point is negative 253 degrees Celsius. We have to show that at 30 degrees Celsius, negative 100 degrees Celsius and 80 degrees Celsius, what are the physical state of this element A, B, C, D and E? So A will be gas as 30 degrees Celsius and A will be gas as well on negative 100 degrees Celsius. Why? Because negative 100 degrees Celsius is greater than negative 253 degrees Celsius, right? So it means at negative 100 degrees Celsius, this will always be a gas as well. And A will be gas at 80 degrees Celsius. This is very obvious because it's already gas at negative 253 degrees Celsius. B. B is having a melting point at 0 degrees Celsius and boiling is 100. Liquid, it will be liquid at 30 degrees Celsius, but it will be solid at negative 100 degrees Celsius because negative 100 degrees Celsius is less than 0, right? So at 0, it's melted, means at 0 degrees Celsius, this element B or this substance B gets into the liquid state. But before that, it is solid state. So at 80 degrees Celsius, this is again liquid because it turns into gas at 100 degrees Celsius. Okay. C part, the C substance is 3700 degrees Celsius. It sublimes. It doesn't convert into the liquid. So we can say that 30 degrees Celsius, negative 100 degrees Celsius or 80 degrees Celsius. It is solid always. And substance D, it's having negative 116 degree Celsius, its melting point, and it gets boiled at 34.5 degrees Celsius. So it is liquid at 30 degrees Celsius and it is liquid at negative 100 degrees Celsius as well. But it is gas at 80 degrees Celsius. Why? 30 degrees Celsius is higher than negative 116 because at negative 116 degrees Celsius, substance D gets into liquid. It gets melted. And it converts into this gas at 34.5. So at 80 degrees Celsius is greater than 34.5. That's why we say that it is converted into gas. But at 30 degrees Celsius, it is still in liquid because it didn't get boiled there. Okay. Now substance E. 108 is its melting point and 1430 in its boiling point. We do have temperatures here which are less than that, so it means this is solid at the all of these temperatures. Now, question B. Which substance has the greatest distance between its particles at 25 degrees Celsius? Explain your answer. Substance A is the answer since A converts into gaseous state at negative 253 degrees Celsius and up to 25 degrees Celsius its particles gain largest amount of energy as compared to other given substances. So they show maximum distance from each other due to maximum kinetic energy they gain. C part. Why is no boiling point given for substance C? Substance C sublimes and does not convert into liquid, whereas only liquid can boil. That's why it doesn't get boiled. D part. Which liquid substance would evaporate most quickly in the open air at 25 degrees Celsius? Explain your answer. Substance A evaporates most quickly in open air at 25 degrees Celsius because its particles have maximum kinetic energy at that temperature. If you have any questions, do write in the comment box, and if you like the video, click on the like and subscribe button, share it with your friends, and do not forget to press the bell icon. Thank you very much for watching. Thanks. Bye bye.